Okay, today I'm going to discuss the Viterbi algorithm for tagging sentences, meaning for putting the part of speech of different sentences. This is the algorithm right here. And I'm going to assume that you had a program that actually went through a file that was pre-tagged before, a corpus or a set of text that was pre-tagged before, and you obtained certain, what we call the parameters. So for example, what is the likelihood of seeing a noun, a verb, and an adjective followed by a noun, for example, and also what is, for example, the likelihood of seeing the word practice tagged as a noun, and so on and so forth. Okay, I'm just going to assume you've seen those. So, with that in mind, I'm going to trace the Viterbi algorithm to show you how it works and how this can be done. So let's begin. First of all, you need a sentence of n words, x1 through xn. These are the words. And we have one. Our sentence is going to be practice long hours. It's a very short sentence, right? Where x1 is practice, x2 is long, x3 is hours. So our n is 3. The parameters q of 3 different tags, tag s, tag u, and tag v, and the emissions of any given word with their tags. And I just showed you that earlier. We're going to initialize this, and we're going to have to store a table, we call it pi. I'm going to have to store the table pi that will have 3 indices, an integer and 2 strings. The indice mean this is an integer which will indicate number of a word, and these are tags, possible tags. Okay, so we're going to initialize pi of 0 star star to 1. Let's do that. So pi of 0 star star, so the pi value of this is going to be 1. As you can see, I have a BP value here because later in the algorithm we're going to use that BP value of the same indices as pi. You can see that. So I just prepare for a data structure to hold this. And then I need variables to store the sets -1, the set 0, which basically have one element, just the star, and the sets 1, 2, 3, which will store all our possible tags. So this S, just without any index there, is all possible tags. And our possible tags, for simplification, are going to be just V, N, and JJ right here. So S-1 and S0 only have one element, which is the star, and S1, 2, and 3 are going to have 3 elements, V, N, and JJ, assuming those are all my tags. Of course, you're going to have a lot more tags than that. Then we're going to need variables for K, U, V, and W. This little thing here, the max, it's how to compute the max for all values of W, right? So we'll need to store the values of W. And then the argmax is not what is the highest value here, but instead what value of W produced the highest value in this equation. So let's begin. We're going to start here. We're going to initialize K. The first iteration is going to be 1, right? So let's set K to 1. U, it's in the set of SK-1. So K-1 is 0. So the set 0 only has one element, star. So we're going to put here star. And then we're going to go here to V, which is in the set of S sub K, which is S sub 1. S sub 1 is V and JJ. So the first element of that, we're going to iterate over that set. The first element is V. Then we go into, then we go inside the for loop, and we're going to compute these two things. So the first one is going to be, first, the table entry is going to be pi of KUV. Pi of KUV. K is 1, U is star, and V is V. So let's compute that. All right. So we're going to loop. W is going to loop through all the values of sk minus 2. Again, s is 1. So k is 1. Minus 2, that's negative 1. So s of negative 1 is just the star. So what this is saying is that W is going to loop through all the elements of s minus 1, but there's only one element. So W is going to get the value star. And then we're going to compute pi of k minus 1 WU, which you see here in the Excel spreadsheet as well, Q of V WU, which you also see here in the spreadsheet, and E of XKV, which you also see here on the spreadsheet. So I put them on the spreadsheet for simplicity, but the spreadsheet has the same things as that you would have to compute. So let's do this. Let's begin. Okay, so with star, what is pi k minus 1 WU? Well, k minus 1 is 0, because k is 1, minus 1, that's 0. So this is pi of 0, W is a star, and U is also a star. So this is the pi of 0, star, star, which we initialized here at the beginning. That's 1. Now, what is Q? Let's tag, letter V is actually the tag V. W is a star. I'm just replacing the letters here. And U is also a star. So our parameter of QV star star. Let's go to our parameters. And we look for QV star star right here is 0.5. So we put 0.5 right here. And then the emission of XKV. K is 1. X1 here is practice, right? So the emission, which is the likelihood that practice is tagged as V. So we're going to look for E of practice tagged as V. Right here, 0.6. So 0.6. So we get that pi of 1 star V is 0.3. 0.3, right? And BP is actually the argmax. What value of W resulted in the 0.3? Well, the star. Because there's no other value of W to be had. So we finish this inside loop here. And we're going to continue with we're going to go back to the for loop, right? So we finished this portion. So we go back to here and we iterate over the next element of V. The next element of V of letter V will be N, right? Remember, V is iterating over S of K, and S of K means S of 1, and S of 1 is these 3 elements. We started with V, we move to the next element, which is N. And we go inside the for loop here, this pi and BP computation. We're going to look for, now we're going to try to compute the pi of KUV again. What is KUV? 1 star N. 1 star N. That's the pi we're going to try to compute. W is going to loop through all the elements of S of K minus 2. K is 1, minus 2, that's negative 1. So W is going to loop through all the elements of S of negative 1. So all the elements in this set, which is basically one element. So we're going to have a star. And we're going to do the same computation. Pi of k minus 1, so pi of 0, star, because W is star, and then U is also star. So pi of 0 star star is 1. We had it right here. Then we're going to do Q of V, which now has the value of N, W, which is a star, and U, which is a star. So Q of N star star. Q of N star star right here is 0.4. We go back to our table, 0.4. And then the emissions of XK given V, XK is 1, so X1, which is practice, and the tag is N, V is N. So practice as a noun, practice as noun. Do we see that here? Yes, practice as N is 0.4, 0.4. So we get a value here of 0.16. 0.16, and the tag that generated this value was the star. because again, there's no other tags to be had. We finished this part. We increase V. We loop through the next element of the set. V now takes the value of JJ. Remember, we're looping here. W is still looping through S of K minus 2, basically of S sub minus 1, which is this one. So we get the value of star, and let's look at the pi. Pi of K minus 1, so pi of 0, W is a star, and U is a star. Pi of 0, star, star. Right here again is 1. Then we're going to look at a Q of V, which is JJ, given W, which is a star, and U, which is a star. What is the value of JJ star star? JJ star star is 0.1. 0.1. And then we're going to look at the emission of practice, which is x sub k, x sub 1, because k is 1. The value of practice tagged as JJ. Practice tagged as JJ. We don't see it here, so we're going to assume this rule, which is 0 if we don't see it. So this whole thing is going to be 0, and we're trying to compute pi of KUV, which is 1 star JJ. That's going to be 0, and the star that and the tag that generated 0 was W. Was star. Now, what happens is we finished looping through V, right? We finished looping through V. So we finished looping through V. Now we need to loop through U. But U was looping through S of K minus 1, right? And K is 1, minus 1 is 0. So U is looping through S0, which is a star. And you already have the value of star. So we're done with looping through SK minus 1 at this point. So we increase K. We're going to increase K to 2. Yes? Now, K is 2. We're going to go back here. Then what is 2 minus 1? Well, 2 minus 1 is 1. So U now is going to loop through S1. And S1 is now these three things. So the first value there is V. V is going to loop through S2 because K is 2, S2. And S2, again, is also these three tags because any S above 1 is these three tags. So the first one is V, right? And the loop continues. We're going to look for an entry for pi of KUV and BP of KUV. So K is 2, V, V. That's U and V. Let's look at it. So W is going to loop through S of K minus 2. K is 2. 2 minus 2 is 0. So W is going to loop through S0. And S0 has just one element, the star. So we're going to use the star. And we're going to look for pi of 1, because K minus 1 is 1. We're going to look for pi of 1 star V. 1 star V right here, 0.3. Then we're going to look for Q of V given star V. I'm just replacing. W is a star and U is a V, right? Q of V given star V. So I'm going to look in my parameters. Q of V given star V is 0.3. So I'm going to replace 0.3 here. And then the emissions now is K is 2. So this is X2, which is long. So I'm going to look for the word long with the tag V. Long with V. Long with V is 0.4. So I'm going to put here 0.4. And that results in 0.036. 0.036. Right there. And the tag that generated that was a star. So we erase this. We increase. Remember, we're looping through V. So we're now going to loop through the next element, which is N. And we're going to do the same thing. W is still looping through S of K minus 2, which is S0, right? So we haven't changed that. This is still S0. Okay, so S0 only has one element, which is the star. So W will be a star. And we compute this, we need to compute the entry of KUV. KUV. So pi of k minus 1, which is 1, pi of 1 with a star with a V. You see this is not changing. So 1 star V, right here. 1 star V is 0.3. Then we're going to look for Q of n given V given star V. Let's look at n given star V. Q of n given star V is 0.3. So 0.3. And then the emissions here is the word number 2, because k is 2. So long tagged as n, because that's the value of V. So long tag as n. Long tag as n, we don't see that ever, so that's 0, right? So that tells us that this pi of 2vn is 0, and bp of 2vn is the star, because the star generated this value, this maximum value. Now, we loop again. The next element here is jj, right? W is still looping through S0, so it's going to be a star, and we're going to look for pi of 1 star V, which is 0.3. We're going to look for Q of JJ given star V. And if we look at the parameters, JJ given star V is 0.3. Whoops. It's 0.3. And we're going to look at the emission of long, that's the second word we're looking at, long as a JJ. And long as a JJ is 0.6. So 0.6. And we get a total. This is, by the way, I'm storing the multiplication here. It's 0.054. So the pi of 2v JJ is 0.054. And the tag that generated that was the star, and we're ready to then do the next iteration. Now, V already iterated over everything. So if you're following, right, V is done iterating. So now we need to go to the next iteration of U. Whoops, right? U needs to iterate now. So we're in that line. We're moving U. U will go to, it was V, now it's going to go to N. And we start all over again with V. So we start all over again with V. So V will become the tag V. W is still iterating over S sub 0, because K is 2 minus 2, that's 0. So basically still the star. So now we're going to look at pi of 1, k minus 1, 1 star n. 1 star n is 0.16. Here we're going to look for Q of V, which is the tag V, W, which is a star, and U, which is an n, right? Q of V star n. Let's look at that. Q of V star n. Q of V star n. We don't see that. So we're going to assume 0. We're going to use the general rule. So we're going to assume 0. So this whole thing is going to be 0. Whoops. This whole thing here, whoops, it's going to be 0. So remember, the entry that we're looking for is 2NV. So 2NV is going to be 0, and the tag that generated that was a star. Okay, then this one increases. Whoops, so we delete this one and this one and this one. V increases and it's now N. W is still looping through S0, so it's a star. And here we're looking for pi of 1 star N. And 1 star N is still 0.16. 0.16. Q of V given WU, Q of V, which is N, given WU, which is N, would be Q of N star N. Let's see if we see it. Q of N star N. We do not see it, so that's 0, right? So the entry that I'm trying to fill out is 2 and N. 2 and N is going to be 0, and the tag that originated that was a star. So, whoops. Now we move to JJ. W is still looping through S sub 0, so it's a star. And we'll look for pi of 1 star N, which we're doing a lot, 0.16. And here we're looking for Q of JJ given star N. If we're looking at our parameters, JJ given star N is nowhere to be found. So that's a 0. So the entry 2NJJ is 0, and the tag that created the 0 was a star. So let's remove this. Now, I've looped through V already, so I'm done with this part of the loop. So I'm going to go here. I'm going to increase U. I'm going to increase U. U was N, now U is JJ. And I'm going to go back now to this loop. So V will start again. We're 2, so S2 is here. So will be V. W is still looping through a 0, so a star. And we're looking now for pi of 1 star JJ. 1 star JJ, which is 0. Right? Which is 0. So the entry 2 JJ V is going to be 0, and the tag that created that is star. I don't bother with the other probabilities because the multiplication is going to be 0. Now this iterates over N, right? So now I'm looking at the entry 2 JJ N, and 2 JJ N, W is still looping through just the star. I need pi of 1 star JJ, and 1 star JJ is 0. So this thing is also 0 with a star. This guy iterates 1 over to JJ, and I'm looking for the entries 2 JJ JJ, which basically this says what are the chances that the word number 2 ends in tags JJ JJ. That's the sequence of tags. So again, W is star, and this is going to be pi of star of 1 star JJ, which is 0. 1 star JJ is 0. So this value is also going to be 0, generated by our friend, the star tag, which basically indicates the start of a sentence. Now, we've finished this one. We've finished this one, right? So let's look at our later program. We finished this one. We finished this one. So we increase K now. Okay? So we increase K to 3. Now, if K is 3, then this is S2, because K minus 1. This is S3, right? And this here is going to be S1. Okay? So K is 3. Now, U is going to iterate over the, U is going to iterate over S2. S2 is this. So U is going to start with the first symbol of that set, which is V. Then we move to the next line. V is going to go over S3. V is going to go over S3 right here, right? S3. So the first tag of that set is V. All right? And now we go into the inner for loop here, right? And W is going to iterate over all elements of S1 computing this thing, okay? So let's iterate all the elements of S1. S1 is V and JJ. So we're going to iterate over V, N, and JJ. So let's do tables here. Now, we're going to look for the entry KUV. We're trying to get the entry KUV. So that would be 3VV. That's KUV. So what is pi of k minus 1, 2, W, which is V, right? So pi of 2 V, pi of 2 VV, 0.036, 0.036. What is Q of V, because that's the letter V, W, which is V, and U, which is V. So Q of V given VV. I don't see it in the parameters, so I'm going to assume 0. So we know that that's 0. Now we compute this one. What is pi of 2 N V? Pi of 2 N V. Here, 0. So that's 0. And what is pi of 2 JJ V? 2 JJV is 0. So that's going to be 0 right there, right? So they're all 0. So the value here is going to be 0, and the tag that generated that 0, well, you pick, because they were all zeros. So I'm just going to put JJ because it's the last one that we had, okay? So, so we have that. Now, I'm getting to the end of the table here, and I'm going to need a lot more table. So I will do something. I will do something later. So we did that, that's 0. So now we iterate over the next tag here, N, right? So again, we're still iterating over V here, right? So N. Let me get clean stuff here. N. W still iterating over S1. So what is pi of 2 V V? Pi of 2 VV, 0.036, 0.036. Here I'm going to have Q of V, which is the tag N, W, which is the tag V, and U, which is the tag V. So Q of N, VV. Let's look at here. Q of N, VV. I don't see it, so I'm assuming 0. So that's going to be 0 regardless of what emissions we have. Now, what if W is now N? Well, we're looking for pi of 2NV. 2NV, that's 0. So that's not good. That N is 0. So we move with JJ. What is pi of 2 JJV? 2 JJV is 0. So we put a 0 here. We do the same thing. So we now have that 3VN. The pi of that is 0, and the back pointer is also going to be just the last one, because there's none of these generated a bigger number than any other. So we now go and erase this. This now switches to JJ. And we again iterate over W. So V, right? So what's the pi of 2V? 2VV, 0.036, right? So 0.036. Q of V, which is JJ, given W, U. Well, JJ with VV, we look in the parameters. JJ with VV is not here. I don't see it, so that's 0. So that value is 0. Now if W is N, we have pi of 2 NV. Pi of 2 NV, we've seen it many times, is now 0. And the same thing with pi of 2 JJV is also 0. So again, we have that pi of 3VJJ, again, KUV, right, is also 0. And the tag that generated that, you can randomly pick is JJ, for example. Okay, so then as you can see, we finished this loop over here. We finished this loop. We're moving U. U was V, now U is going to become N. Remember, we're looping in this set. And now we go back to looping on V. So V starts with the tag V. So let's look at this. W is still looping through S1 because K hasn't changed. So what is pi of 2 V N? 2Vn is 0. Okay, that was easy. Now if W is N, we're going to do the pi of 2 N N. What is pi of 2 N N? Is also 0. And then with JJ, we're going to do the pi of 2 JJN. 2JJN is also 0, right? So if I'm looking at, now I need to fill out the pi of 3NV. And the pi of 3NV is also going to be 0. Now, I'm running out of space here. So what I'm going to do is I'm going to erase all the back pointers that are 0. We're going to just assume that the pi is 0 here, okay? We're going to just assume that the pi is 0 and the tags are, you know, if it has a 2, the tag is going to be a star. If it has a 3, the tag is going to be a JJ, just because I need the space. So I'm going to clear the contents there. So now I'm looking at pi of 3 and V, okay? And 3 and V is going to be 0, and the tag that generated that is going to be JJ. All right. Now we move V to N. Notice the following. This pi of K WU does not depend on N. So it doesn't matter what N is. These are still going to be 0. You can try this, right? So I would say 3 and N is also going to be 0, and the tag is going to be JJ. Again, when V now iterates to JJ, we're going to have the same thing. This pi doesn't depend on V. So it's going to have 3 and 3, I'm sorry, 3, yeah, all 3 in N is going to be 0, all 3 V, 3 and JJ, I'm sorry, 3 and JJ is also going to be 0, right? And the tag is going to be JJ. And then we're done here. We're done doing this loop here. We need to iterate over U again. So the next value of U, it's going to be JJ. And now we again start our iterations on V. V is going to start with the tag V. And now we're going to look at pi of K minus 1, which is 2 V JJ. Pi of 2 V JJ. That's 0.054. We're going to look for Q of V, which is the tag V, W, which is the tag V, and then U, which is JJ, right? V of V JJ. V of V JJ. I don't see it, so it's 0. So this value is going to be 0. We're going to look for the pi of 2 N JJ. 2 N JJ. If I don't see it here, it's because I erased it because it was 0, right? And then the same thing with the pi of 2 JJ JJ. I erased it, so it was 0. So these are all zeros. So the pi of 3 JJV, remember the pi of 3 of KUV, is 0. The tag is going to be JJ. Why? Because I randomly pick a tag that generated, because no value here was bigger than any other value. They were all zeros. So I just pick whatever tag works. All right. Now we iterate for the next tag here on V, N. So we do, again, pi of 2v jj, 2v jj, where's that? Here, 2v jj, 0.054, right? Q of v, which is n, w, v, and then u, which is jj, q of nv jj. Q of nv jj is 0.4, whoops, 0.4. So we replace that 0.4. And then the emission, K is 3. So X3 is hours. So hours with the tag N right here, right? So hours with the tag N. Hours with the tag N. Hours with the tag N right here is 0.7. 0.7. All right, so that's a value. Now we're looking for pi of K minus 1, which is 2 N jj, 2n jj. It's not here, so it's 0. And the same thing happens with 2jj jj, which is 0. So now here's what's the maximum value, right? For 3jj n, the maximum value was 0.015, and the tag that generated that maximum value was v. All right, we erase this and we move to the next tag, jj. So what is pi of 2v jj? 2v jj is 0.054. So these things, as you notice, they don't depend on v, so that they will be the same, right? 0.54 q of v, which is jj, given v jj, jj of v jj is not here, so I'm assuming 0, so that's going to be 0. This pi is 0 as well, just like in the previous cases, is 0 again, right? So there's no maximum here, so the entry of 3 jj jj is going to be 0, and the tag I'm just going to assume jj. All right, so at this point I've exhausted v. Oops, I've exhausted v. So we're going to go here, we're going to increase u, but u already reached the end of the set. So I'm going to increase k, but k only goes to n, and n is 3, so I'm done with k. You see that? I'm done with k. So I'm done with this set of for loops here. I'm done with this set of for loops here, right? I'm done with that. So now I'm going to go to this, okay? I'm going to create a set of tags, okay? N is 3. So I'm going to say that this is 3 minus 1 is 2, and this is 3. N is 3, because that's the number of words. So I'm going to go here. This is going to be y, set y, right? And y, 1, 2, 3, right? All right, so y sub 3. So these two tags are going to be the two tags over u and v. I'm going to vary u and v, all possible values of u and v, okay, or over my tags. And I'm going to look at pi n uv times the probability of stop with u and v. Okay, so let's do that. I'm going to look at, this time I'm going to look at pi of nuv, oops, sorry, nuv, pi of nuv times the probability of stop with uv times the probability of stop, or the likelihood of stop with u and v, and there's no emissions. Okay, so, and then here I'm going to vary u, right, and v. and v. So I'm going to vary u and v here. Just for simplicity, I'm going to vary u and v over here. It's the same thing, or I'll just put the u and v for the max. So u is going to be v, v, and n. Whoops, and n here. Remember, and this is n is 3 because that's where we stood. N is 3. So I'm going to look at pi of 3 VV. 3 VV. If I don't find it here, it's because it was 0, right? Times whatever, it doesn't matter, that's 0. And then the value of, that's 0. Now, I'm going to increase V to N. And I'm going to do a pi of 3 VN. 3VN, 3VN, 3VN. Not here, so it's 0, right? So it's still 0. I'm trying to find the maximum here, okay? So N, and now V becomes JJ, so I'm going to do pi of 3 JJ V. 3 JJ V is 0. So this, this is still 0. I move this value up 1, N, and this value goes back to V, iterating again. So we'll look at pi of 3 N V. 3 NV is 0. We iterate, we move this one to N. I'm just looping through these variables through this set, okay? So now what is pi of 3 and N? Is also 0. So this moves to JJ. What is the pi of 3 and JJ? 3 and JJ is also 0. So that didn't work very well. So now this guy moves to JJ. And this guy moves to V. So what's the pi of 3 JJ V? 3 JJ V is 0. This guy goes to N. What is 3 JJ N? 3 JJ N is 0.015. 0.015 times the Q of stop given JJ and N. What is stop of JJ and N? Stop of JJ and N is right here, right? Is 0.5. So 0.5, that gives me, I'm just going to multiply these two. That gives me 0.08, okay? So 0.08 with JJ and N, okay? So 0.08 with JJ and N. This is going to become important. I'm going to register this tags, JJ and N. I keep looping. I need to find out which tags give me the biggest number. So I'm looping through V. N is now JJ, right? So what is pi of 3 JJ JJ? Is 0. So yeah, so it turns out that the tags that gave me something, and actually the maximum, were JJ and N. So I'm just going to erase this. JJ and N. And JJ and N become, as the algorithm say, Y2 and Y3. So JJ and N. That's Y2 and Y3, right? Now, what we're going to do next is we're going to loop through basically all the remaining values of N. So N starting with N minus 2, which in our case, because we only have 3 words, it's going to be the value 1. So it's just going to be 1 to 1, okay? But we're going to do this. We're going to do Y sub k, which will be Y sub 1. Y sub 1, this value. It's going to be the back pointer of k plus 2, which is 3, back pointer of 3, right? With y of k plus 1. So k is 1, plus 1 is 2, and k plus 2 is 3. So I'm going to look at the back pointer of 3, 2, 3. Back pointer of 3, 2, 3. I'm sorry. Back pointer of 3 with y2 and y3. y2 is jj and n. So I'm going to look at the back pointer of 3, jj, n. 3, jj, n is v. That's the back pointer, is v here. V. So the tag that best fits this, the tagging that best fits this is to tag the third letter as n, the second as jj, and the last one as, the first one as v. These are the tags, the sequence of tags. So that's how we get the sequence of tags using the back pointer and the Viterbi algorithm, and practice is the verb, long is an adjective, and hours is a noun. That is the maximum, the sequence of tags that result in the most probable tags for this sentence: v, jj, and n. And this is how we work with the Viterbi algorithm.